Good day, students. We are going to be looking at Chapter 6, Lesson 3 on the behavior of gases. Some of the key concepts that we're going to look at in this section are how does it connect molecular theory, describe the behavior of gas, how are temperature, pressure, and volume related in Boyle's law, and how is Boyle's law different from Charles' law. So first off, let's talk about the kinetic molecular theory. And this really is a way to help us explain how particles and matter behave. So some of the basic ideas that we see with this is that all matter is made up of small particles. These particles are constantly in motion, and it's random. They just go from one point, hit, go to another point, hit, go straight line, hit another place. They're just bouncing around, and they just will collide with other particles and objects. What we're going to see that each time they collide, they're transferring their energy. We're not seeing that energy is being lost. It's just being transferred from one form to the next, kind of like a game of pool, looking at the billiard balls, and you're transferring energy from one ball to the next. If we look at pressure, pressure is the amount of force applied per unit of area. So gases are the easiest ones to compress and to increase their pressure because they have empty spaces between their particles. You can push them together. A solid, you're not able to apply a lot more pressure to because the particles are already really close together. So pressure is equal to the force exerted on a surface divided by the total area which the force is exerted. So pressure really is force divided by area. We look at force being, just to remind you, is in units of newtons. Area is in square meters. So we could say that pressure is measured in newtons per square meter, but to shorthand that, they call the unit of pressure Pascal. So some ideas with pressure: as the force increases over a given area, the pressure increases. If the force decreases, the pressure will decrease. If the area increases, the pressure will decrease. And if the area decreases, the pressure will increase. So what you're going to see is that they're opposites. If we see talking about force and pressure, if we're talking about area and pressure, we're going to see they're opposites. If you see the area getting larger, you're going to have less pressure. Now, force and pressure, they go hand in hand. You increase one, you're increasing the other. So here, just giving you an illustration, talking about this illustration right here is looking at the greater the volume, the less pressure. And the reason behind that is these particles have more space to move around, so they're less likely to come into collisions with the container. So let's look at Boyle's law here. I'm just going to slide this up so you guys can see everything. Boyle's law states that the pressure of a gas increases if the volume decreases and the pressure of the gas decreases. If the volume increases when the temperature is constant. So this is really looking at what we're going to do with Boyle's law is we're going to keep temperature constant, and we're going to look at how volume and pressure are related to one another. And so what we will see is states that if the temperature is kept constant and the volume in the container is decreased, the pressure will increase. So we're going to see opposite reactions. So if we cause the volume to go down, as we're seeing here in this picture, then what we're going to see is we're going to see that the pressure will increase. We'll look at some different examples, and the equation that we use with this is volume equals pressure, then initial pressure times the initial volume divided by the final pressure. And we'll look at how we can use that equation to solve simple gas law problems. We also can talk about Charles' law, and you'll need to fix a couple things in your notes here. I got things flipped around a little bit. And how you want to write this, it states that when the pressure of a container is kept constant and the temperature is increased, the volume increases. So if you need to flip-flop volume and pressure, please do so. It may already have been corrected in your notes. So it states that when the pressure of a container is kept constant and the temperature is increased, the volume increases. So here we're looking at, this is Charles' law. You're going to keep the pressure constant, but we're going to play around with volume and temperature as our variables. So here it's showing that if you have a lower temperature, you're going to have less volume. Those particles don't have as much motion. They don't have as much energy, so they're not as likely to bounce around. They're not going to cause as many collisions. They're not going to cause things to be pushed out. Whereas if it's in higher temperatures, they have more energy, they're causing more collisions, they're going to run into the side of the container more often, they're going to cause that to, the volume to be expanded. So again, the idea is that if you have an increase in temperature, you're going to have more kinetic energy, so you're going to have faster collisions, which is going to equal greater pressure. So here's just kind of reviewing that. Charles' law states that the volume of a gas increases with increasing temperature if the pressure is kept constant. So the volume of gas increases when the temperature increases at a constant pressure. So they can kind of show, here's a graph showing, looking at, you have volume on this side, we have, slide up a little bit, temperature on the bottom here, and it's talking about temperature versus volume for a fixed amount of gas at a constant pressure. So they're showing that these different gases, as you go up in temperature, we're going to see that the volume also goes up. So just kind of giving you a relationship. The key thing to understand between Boyle's and Charles' law is which variable is kept constant. Both of them deal with volume, pressure, and temperature, those three variables. Boyle's law is going to keep temperature constant, so the only things you're going to work with are volume and pressure. And Charles' law is going to keep pressure constant, so you're only going to work with volume and temperature in that one. So it helps if you can remember with the Boyle's and Charles' law, which ones you're going to keep constant, so then you know what you're going to be working with from there on out. Again, come with questions to class, and we will go from there. Thank you.